Let's look at a couple of problems involving determining the number of digits a number has. So first off, think about it this way. If you're looking at a number, you're really trying to put that number in a slot between 1, 10, 100, 1,000, and so on. Because 1 is the smallest integer that has one digit, the smallest positive integer that has one digit. 10 is the smallest integer that has two digits. 10 squared is the smallest integer that has 3 digits, 4 digits, 5 digits, right? So if you run into a number like 836, because it falls between 10 squared and 10 to the third, you know that it has 3 digits, right? So you find a problem like find an integer n, so that n to the 1266 has 1144 digits. I know it better be less than 10 to the 1144. That's the smallest 1145 digit number, a 1 and then 1144 zeros, and bigger than 10 to the 1143. That's the smallest 1144 digit number. So since your variable is in the base, I can actually take, I know this sounds strange, but I can take the 1266th root of all these numbers and the order will be the same. So 1143 to the 1 1266th is less than n 1266 to the 1 1266th, 10 to the 1144 over 1266. Well, these are numbers I can kind of crank out, given a nice handy-dandy calculator. 10 to the 11, oops, I guess I need a parenthesis, 1143 divided by 1266. Well, that's 7.995. And then if I took that same thing and put in 1144, this is now pretty obvious that my integer n needs to be 8. So that's how that works out. You can check it, but not, of course, the conventional way, because n 8 to the 1266 is way bigger than your calculator can sort of handle. But if you want to know how many digits it has, of course, our standard way of dealing with that is take the log of that, which of course is log base 10 of 8 to the 1266. By the power rule, you can bring that out, crunch out how many digits that'll have, and that'll be a number just smaller than 1144. So it'll have 1144 digits. We're going to have to do something similar to that with this problem. Now I've got my power here, so now I need 15 to the k somehow to be between 10 to the 1144 and 10 to the 1143. Okay, so now I've got my variable in the exponent. Well, that's challenging because, of course, I don't know, I can't just take a root to get rid of the power like the last problem. So I'll take the logarithm of all these. Now the nice thing is, if you took log, let me just write to the side here, log base 10 of 10 to the 1143. Can you see this says 10 to what power is 10 to the 1143? Log of this, log base 10 of this, is just 1143. Log base 10 of this is 1143. Log base 10 of this, you could write it as log of 15 to the k, or I'll just write it as k times log 15. Now I can just divide by log 15, dealing with insanely large numbers here, but I can do that using logarithms. So go back to calculator land here. 1140. Oops, and this somehow became, miraculously that changed to a 3 when it should have been a 4 all along. Okay. So, let's see what I need to do here. I need to do 1144 divided by log 15. That's, so I'll try and clean that up just a touch here. That's, let's see what that number was. That was 972.7. Okay. And let's see, then if I do the same thing with 43, it's kind of handy that you don't actually have to put the right parentheses in these calculators to have it do the right calculation. It'll assume that you've closed everything off. That's 971.86. So, of course, K is then going to be 972. There you have it.